Hey, what's going on, guys? Let's do this problem right here. We have the question is asking the current supplied by a battery as a function of time is I is equal to 0.88 ampere e power minus t over 6 hour, right? So this is actually over, right? 6 minus t over 6 hour. What is the total number of electrons transported from the positive electrode to a negative electrode from the time the battery is first used until it's essentially dead? Right. So to find this one, what do we do? We usually use this equation that q is equal to integral going from 0 to infinity I dt. So this is the equation we are going to use. So here they already have given the function of I, so we can simply substitute and find the charge first, because we are going to use this to find the number. The question is asking what is the total number of electrons, right? To find the number of electrons, we need the Q, because we are going to use N is equal to Q over E, right? If we know the charge, then we can find the number, because we know the electrons charge, that's 1.6 times 10 to the power of minus 19, but we don't know the charge. To find the charge, we have to use this equation. So let's plug all the values and see what we get, right? So this is going from 0 to infinity, and we have the function of I, that is 0.88 ampere times e power minus t divided by 6 hour, right? 6 hour dt. So this is what you have. Since we have this 6 in hour, we have to convert this into 6 second. In 1 hour, we have 3,600 second, right? 3,600 second. So 0 to infinity, 0.88 ampere times e power negative t, 6 times 3,600 is going to give us 21,600, right? 6 times 3,000, yeah, 21,600 second dt. Now all we have to do is do the integration. Since everything except t is going to be a constant, so we can move this 0.88 ampere to the front. So this is going to be 0.88 ampere, 0 to infinity, e power negative t over 21,600 second dt. So here, if you do the integration of this one, this is going to be 0.88 ampere. Integration is going to be e power negative t over 21,600 second divided by negative 1 over 21,600, right? Going from 0 to infinity. So this is going to be the integral. We can move the negative to the front, and also this 21,600 is going to be flipped and going to the top. It's going to be on top. So this is going to be negative 0.88 ampere times 21,600 times e power minus t over 21,600 second, going from 0 to infinity, right? So this is what we have right now. So let's apply this 0 and infinity and see what we get. So for this one, like this is going to remain the same, negative 0.88 ampere, 21,600, and then in the bracket, first if we apply infinity, so this is going to be negative infinity, e power negative infinity is 0, so that's going to be 0. And if we apply 0 right here, e power 0 is going to be 1, right? So we get, this is not plus, this is minus actually. This is minus. So 0 minus 1, and then here we get a negative answer. Negative times negative is going to be positive, so the final answer is going to be positive. And if you multiply this 0.88 times 21,600, that's going to give you 19,008 coulomb. So we have the charge right now. Now we can use this one to find the number, right? That's the question, number of electrons. So number is going to be basically Q over E. Here we have the coulomb, that is Q, 19,008 coulomb divided by electrons charge, that is 1.6 times 10 to the power of minus 19 coulomb, and that's going to give us 1.2 times 10 to the power of 23 electrons, right? So this is going to be our electron, 1.2 times 10 to the power of 23 electrons. So that matches this answer right here. So this is the correct answer. So that's how we do these problems, and let's do the second problem. The second problem is asking if an electric device delivers a current of 5 ampere for 10 seconds, show how many seconds, how many electrons flow through the device. So they are asking for the number of electrons. So here we have ampere, I is equal to 5 ampere, and we can write this one as 5 coulomb per second. That's also the same thing. And also I is equal to Q over T, right? So Q over T. So from this one, what we can find? We can find the charge, and also we already know N is equal to Q over E, right? So if you can find the charge, we can use this one in this equation and find the answer. So let's find the charge first. Q is equal to IT. So I is 5 coulomb per second times 10 seconds, and that's going to give us 50 coulomb, right? 50 coulomb. 50 coulomb. Now we can apply in this equation. That's going to be N is equal to Q over E. Q over E. So Q is 50 coulomb. Electrons charge is 1.6 times 10 to the power of minus 19 coulomb, and then this will give us 3.125 times 10 to the power of 20 electrons. So this is gonna be the answer for the second one, right? So this is the number of electrons we are going to have, and the answer for the first one is right here. So this one we already put it right here. This is the one, and that's how we do these kind of problems. I hope you guys find this video helpful. Thanks for watching.